In this video, we are going to be using the fundamental theorem of algebra to solve polynomial equations with complex roots. The fundamental theorem basically says that if you have an nth degree of polynomial, then you're going to have exactly n roots. Meaning, if you have an x to the fifth plus x cubed plus x plus 2, that means you are going to have 5 zeros. Why? Because the highest exponent is going to tell you exactly how many zeros it has. So x squared plus x plus 5 means you're going to have 2 zeros for your answer. Why? Because the highest exponent is a 2. So no matter what the highest exponent is, that is the number of zeros that you are going to have in your answer. So back when we've discussed this in the past, finding zeros of polynomials, the 3 steps are: first, look for all the possible rational zeros. And then if you're left with a quadratic, you're going to factor. And if the quadratic cannot be factored, then you must use the quadratic formula. So if we look at the constant and we look at the leading coefficient, that means all of the possible zeros are going to be all of the factors of 36. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. All because those are the factors of 36. So any one of these will work in this. But we got to figure out which one. So we create the shelf. And now we got to figure out which one is going to work, or which 3 hopefully will work. Because how do I know there's 3 answers? Because it's an x cubed, which means I know I have to look for 3 answers. So I'm going to start off with 2. No idea. Let's just figure out if it works. Bring down the first, multiply, add, multiply, add, multiply. That does not give me a remainder of 0. So let's start over. We might need to get something that's a little bit bigger then. So if 2 didn't work, we could try 4. So bring down the 1, 4, add, multiply, add, multiply, and we actually got a remainder of 0, which is great. So we know that x equals 4 is a 0. What we are left with is a quadratic, because don't forget, this is the constant. This is the coefficient in front of x. This is the coefficient in front of x squared, which means we can rewrite this as 1x squared plus 9, because there was no x. We can now set that equal to 0 to find our other zeros. So to solve, we would subtract 9 from both sides, and then we would take the square root of both sides, and we'll get plus or minus 3i. Don't forget, when you take the square root, it's going to be plus or minus, and it's an I because there was a negative inside the square root. So x equals 3i was a 0, and based off of the conjugate theorems that we have discussed, the negative 3i, both of them come in pairs. And we found 3 answers. The highest degree was a 3, so we found all of our answers. So in this case, we are going to try to find all the zeros. However, this is actually a quartic that can be factored. But let's suppose that you did not notice that it actually can be factored. You can still use the fundamental theorem of algebra and finding all the zeros using synthetic division to try to find the answers to this. So what we're going to do first is we're going to find all of the possible answers. So we are going to look for the coefficient and the constant. The coefficient in front, the leading coefficient is 1, so it's just going to be plus or minus 1, plus or minus 2, and plus or minus 4. So we're going to build our shelf. X to the 4th, there is no x cubed, x squared, there is no x, and then negative 4. And now we need to determine what it will possibly work for this. So I always like to start off with 1, so let's go ahead and start off with 1. So multiply, add down, multiply, add down, multiply, add down, multiply, add down, and that will not give me a 0 for the remainder. So I know that. So 1 does not work. So let's try 2. So I'm going to bring down the 1. Multiply, add, multiply, add, multiply, add, multiply, add, which is great. We actually found a remainder of 0. So we know that x equals 2 works. So now this is not a quadratic because you have a constant x squared, that represents x cubed. So what we're going to do is we create a new shelf, and that now becomes our new. So we know that 2 worked. We could always try -2 to see if it works. So bring down 1, multiply, add, you'll get 0, multiply, 0, add, multiply, and actually you get 0. So now we know that x equals -2 also worked. Now we are down to a quadratic. This is the constant, this represents x, and this represents x squared. So we can rewrite this as x squared plus 1 equals 0. And now we can solve. You would subtract 1 on both sides, and then you would take the square root, and you would get plus or minus 1i. So we found x equals I to be a 0 and x equals -I to be a 0. And again, according to the conjugate theorem, they should come in pairs, which they do. Now, we found 4 answers. The highest degree is a 4, which means we found all 4 zeros. So let's recap. At the moment, I would like for you to pause the video and try to attempt these problems, and then resume whenever you're ready to see the answers. Okay, so what I'm going to do is I'm first going to find all of the possible zeros, which is going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10 based off of our constant. So we build a shelf. I always like to start off with the number 1, so let's see if 1 works. Bring down the 1, 1, 2, 2, -3, -3. Okay, that will not give me a 0. So that did not work. So now I'm going to try 2. All right, so 2, 4, multiply, add. No, that's a positive 3. Multiply. Okay, that will not give me a 0 either. Okay, 2 didn't work, 1 didn't work. Okay, well, let's try 5. 1, 5, 7, 35. We're getting to be some big numbers. 30, 150. Okay, that did not work. That got too big too fast. Okay, let's try a -2 then. 1 didn't work, 2 didn't work. We can try -2. Let's see if that works. So if I bring down the 1, -2, 0, 0, -5, positive 10. There you go. There's our 0. All right, so we know that x equals 0. No, not 0, sorry. 0 was the remainder. We know that x equals -2 was a 0. So now we're going to take what's left, which is now a quadratic, and we can write as x squared minus 5. Now to solve, we would add 5 to both sides, and then we would take the square root. So we'll get x equals plus or minus the square root of 5. So x equals the square root of 5 is a 0, and x equals negative square root of 5 is a 0. We found 3 answers. The highest degree was a 3, which means we found all 3 answers. Next, this is a quartic. I believe it actually can be factored, but I'm still going to use synthetic division anyways. So first we're going to look for the possible zeros. It is going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Build a shelf. X to the 4th, there is no x cubed, put a placeholder. X squared, there is no x, and then our constant. So we need to figure out what numbers are going to possibly get us. So always try 1. So bring down the 1, 1, add, multiply, add, multiply, add, multiply. Okay, that did not give me a 0 for the remainder. So 1 did not work. Let's try 2. 1, 2, add, multiply, add, multiply, add, multiply, and I got a 0, which is great. So we know that x equals 2 is a 0. This does not give us a quadratic though, it only gave us a cubic. So we are going to have to create a new shelf. And now we need to figure out what will work. So we know that 2 works, so, well, let's just try -2 and see if it works. So if I bring down the 1, -2, 0, 0, -2, +4, and that actually worked. So we know that x equals -2 also works, and we are down to a quadratic, x squared minus 2. To solve, you would add 2 to both sides, take the square root, and you would get plus or minus the square root of 2, and that is our other 2 answers. You get the square root of 2, and you would get negative square root of 2. And we found 4 answers. The highest degree is a 4, which means we found all the answers.